Alrighty, let's get into understanding some properties of numbers. It's a bit of a year 5 concept that then spills into year 6 as well. Our learning intention, what are we learning today, is understanding the properties of prime and composite numbers. And I'll go through the definitions of those two things again in a moment. But to understand them, we need to track back to factors. Now, factors, whether or not you've already looked into factors, are numbers that divide into another number exactly without leaving a remainder. For example, the factors of 10 are 10 and 1, because 10 times 1 is 10, but also the factors of 10 are 5 and 2, because 5 times 2 equals 10. So when you're dividing 10 by its factors, you can divide it by 2, you can divide it by 5, you can divide it by 1, and you can divide it by 10. So those 4 numbers are factors of 10. On 6, for example, the factors are 1 and 6, because 6 times 1 gets you to the number 6, but also the factors of 6 are 3 and 2, because factors absolutely times together or multiply together to create a bigger number. So the factors of 6 are 6, 1, 2, and 3. Okay? What are the factors, and this is something you can pause the video for, what are the factors of 24? Pause the video, have a think. All right, hopefully you've paused and had a think. So we're going to start over here with the black lines, 24 and 1. They're both factors because 1 times 24 is 24. Over here, we're going to do another factor. We're going to do 6 and we're going to do 4 because 6 times 4 is 24. Over here, we're going to do 2 and 12 because 2 times 12 equals 24. And finally, down here, we're going to do 3 and 8. They're all factors of 24. 1, 2, 3, 4, 5, 6, 7, 8. You can say that there are 8 factors of 24 because there are 4 ways, 1, 2, 3, 4, of making 24 by multiplying together. A reminder, 24 can be divided equally by all of these numbers. Okay? And when I say equally, I mean that if we were lining up 24 dots, we will be able to make an equal pattern. Now that brings us on to prime and composite numbers, all right? Let's go away from here and zoom in on the lesson today. So a prime number is a number that is only divisible by itself and 1. So when I say that, it means that the number has a factor of 1 and itself only. So the numbers we just saw in those examples, 24, 6, and 10, are not prime numbers because they divide with other numbers. They are what's called a composite number. And a composite number is a positive integer that can be formed by multiplying 2 other positive integers. So not just 1 and itself, but maybe, for example, 3 and 8, or 6 and 4, or 20, or 2 and 12. Okay? A composite number, once again, can be divided equally into other numbers, not just 1 and itself. Okay? Prime numbers are composite numbers. Prime numbers and composite numbers are opposites of each other. Have a look at these numbers just here. We've got the number 7, the number 23, the number 59 at the top, and the number 12, 27, and 60. Have a think about what the properties of these numbers are. Yep, you're absolutely right if you thought about what prime numbers and composite numbers there are. The top section are all prime numbers, and the bottom section are all composite numbers, okay? So let's go through the definition once again of a prime number. The prime number can only be divided by 1 and itself. That is to say that its factors are 1 and itself, and you don't have any other factors. You will not be able to multiply anything together to get to 59 apart from 59 and 1. You will not be able to get to 23 any other way apart from multiplying 23 and 1. And you will not be able to make 7 any other way by multiplying any other integer apart from 7 and itself. A really good way to highlight a prime number is that when you draw some shapes in an array or a scenario, you won't be able to make a perfect shape or a perfect group of dots any other way apart from when you're doing ones. For example, 7 fits perfectly into one group, okay? But if we try to arrange these dots into 2 equal groups, you will see that we are not able to. So it won't go into 2 groups equally. It certainly won't go into 3 groups equally. And if we try to do it 4 groups, no, there's no way I can make it into any equal group. The only group I can make it up into is one group of 7 dots. And that is the exact property of a prime number. The only group you can equally split it into is a group of itself. One group of itself. So one group of 7, one group of 23, one group of 59, and that is a prime number. Conversely, when you're having a look at a composite number of 12, you can see I've got 12 boxes along here, and they split beautifully into one group of 12. But reminder that a composite number has other positive integers it can divide into. So a 12, for example, can split itself into 2 groups of 6, 4 groups of 3, or even 6 groups of 2. Look at that. So a composite number can be split into more divisible integers. So instead of just timesing itself by 1 to get to the number, you can actually multiply it by other numbers to get there. So any multiple of 2, anything that can be divided by 2, is not a prime number because it can be divided by 2. It's actually really important to note that the number 1 isn't classed as a prime number. Yes, it can be multiplied by 1 and itself to create the number, but because there is no other number that it multiplies by, it's just 1 times 1, it is not classified as a prime number. Alrighty, so activities today in maths, and it's a long one today, so take your time with it. The first one is a number grid, and all you need to do is identify the prime numbers by highlighting them. The second activity relates to AFL or AFLW. Choose your preference. You're just researching a team. If you want to do it with netball or a different sports team, that's fine. But your idea really is to find the player's name and their jersey number or their Guernsey number, and identify whether they're prime or composite. So put the team name at the top, player's name in the first column, jersey number, and then whether it's a prime or composite. The final activity relates to a really weird and wonderful video that I've found. And if you haven't seen this person before, it's just a really interesting video. Have a look at the first 4 or so minutes. And it's just a pattern, and I'd love you to create the pattern. It's related to a mathematician called Stanislaw Ulam, which is like a number spiral pattern. Watch the video up to about 2.5 minutes or so, and yeah, have some fun creating a pattern with prime numbers. Apart from that, have a wonderful day, and look forward to meeting you on WebEx after this for the Haas art. Thanks, you guys.